Hey there, welcome to Calculus. This is just a little short bonus video in which I want to illustrate how you can handle chain rule problems that are a little deeper in the sense that they have more than two functions being composed with each other. All right, so we're looking at the chain rule here. It says that the derivative of a composition, f composed with g, is the derivative of the outside function, that's the f of x, evaluated at the inside function times the derivative of the inside function. All right, so that's what the chain rule says. So those are your two layers, inside and outside. And the question I want to answer here is, well, what do we do if we have more than two layers? All right, so let me scroll down a little bit, show you an example. Here, maybe this is the function I want to differentiate. I want to differentiate the sine squared of x to the seventh plus 3. All right, so why does that composition have more than two layers, and what are the layers? I think we want to remember that when you write exponents on trig functions, let me just kind of reveal this here. When you write sine squared like this, what you mean is it's the sine of whatever you're taking the input of a quantity squared. Okay, so you can kind of see the three layers here if I highlight them as I talk about them. If I handed you an x, what would you do to evaluate the output of this function? The first thing you would do to that x is you would take its seventh power and add 3 to it. Okay, so that's the innermost layer. And then what would you do? Once you have the seventh power of x plus 3, then you'd take the sine of it. That's the next layer. And then what would you do to that? You'd finally take that number and multiply it by itself. You'd square it. So there are your three layers. Yeah, this is a composition of three functions. X to the seventh plus 3 gets plugged into the sine, which gets plugged into the squaring function. So when we go to differentiate that, how can we handle it? Well, you'll basically just use the chain rule, always treating it as a composition of the outermost function with however many are inside after that. So let's just sort of scroll up and see if we can't make the computation. I'm going to leave that highlighted piece where we can see it. So the outermost function, when you're using the chain rule, you're gonna start and go outside in. When you use the chain rule, you go outside in terms of the layers. So when I look at this thing, the outermost function is the squaring function. So the derivative of the squaring function is 2 times whatever you're squaring. In this case, that's the sine of x to the seventh plus 3 to the first power, and then you need to multiply that by the derivative of what you were squaring. So I'm just going to write sine of x to the seventh plus 3 prime. All right, so there's just the chain rule. Okay, well that thing that just popped out, sine of x to the seventh plus 3, it itself needs the chain rule. Okay, well, no problem. We'll just continue along here. So I'm going to take this first factor, it's just going along for the ride at this point, 2 times the sine of x to the seventh plus 3. But by the chain rule now, I have to differentiate that inside function. That inside function here still has 2 layers. Yeah, we're still plugging x to the seventh plus 3 into the sine function. So when we go to differentiate that thing, we have to use the chain rule again. So the derivative of the outside function is cosine. The derivative of sine is cosine. And we're going to evaluate it exactly at the same input, x to the 7 plus 3. And then we have to finish that by multiplying by the derivative of x to the 7th plus 3. All right, so I'm going to kind of left justify this a little bit so it looks a little nicer. A lot of this I'm just copying along for the ride. So I've got 2 times the sine of x to the 7th plus 3 times the cosine of x to the 7th plus 3. Finally, the derivative of x to the 7th plus 3 itself is 7 times x to the 6th. All right, so when we're done looking at our answer, we can kind of see why it has the form that it has. I'm just going to use this color coding the same way. Why does it start off 2 times the sine of x to the 7th plus 3? Well, because that was the derivative of the outermost function. The outermost function was the squaring function, and the squaring function's derivative is 2 times its input. And then why is there a cosine next? Well, because the middle function, the sine, the next layer in, its derivative is cosine. So that's just the derivative of the sine function at the same input. And then what's finally this 7x to the 6th out here? Well, that's the derivative of the innermost function. So when you use the chain rule, you just differentiate outside in. Okay, so I hope this was a helpful example for you in looking at deeper chain rules.